Hi, my name is Erin Kim, and today I'll be presenting the work that I completed with Dr. Oliver Schneider, Defining Haptic Experience, Foundations for Understanding, Communicating, and Evaluating HX. Haptic technology is growing, becoming increasingly more incorporated into interactive systems with the intent to improve the user experience. Now, haptic feedback comes in various modalities. We see it commonly in the form of vibrotactile feedback in smartphones and wearable devices, or as force feedback, like in the Phantom devices, which have several applications. We can also see it in the newer electrovibration technology, which uses haptic feedback to render the feeling of specific textures. Now, with this growing sophistication of these technologies, research has demonstrated that haptics certainly do leave a positive impact, building a sense of presence in virtual environments and adding an overall sense of enjoyment and novelty to an experience. And so, while we know that haptics can offer a positive experience, the field has yet to articulate what exactly within the experience of haptics makes it positive. And so we're going to tell you what makes a good haptic experience by defining haptic experience and presenting to you a model that describes its components. Now, why is something like this useful? Well, because without such a model, we're limited in several ways. Consider Raj, our hard-working fellow haptician. Raj has big dreams. He wants to build a note-taking tablet using electrovibration technology that renders the feeling of paper. Now, when Raj puts his mind to something, he is determined to achieve a standard of excellence. And so he says to himself, I'm going to make sure the haptic feedback on this tablet makes for a great experience. But he quickly realizes that he doesn't actually know what he means when he says this. What does it mean to have a good experience with haptics? And so he asks around, and no one really seems to know, and the answers that he does get seem to differ across those he asks. And so the first limitation we run into from not knowing what constitutes good haptic interactions is in the design process. Hapticians like Raj are left without a universal set of design criteria. In other words, Raj doesn't know what to aim for. Now let's say he makes it through the design process and builds a system. Eventually, he'll face another challenge when it comes to evaluation. If Raj doesn't know what the standards are of an ideal haptic experience, he won't know what to measure to determine if those standards have been met. Now, there are evaluation tools that hapticians like Raj could use and have used, like those that measure presence, affect, and user experience. And while these are useful, they don't reference the haptics themselves. And so for someone like Raj, who's interested in identifying areas that need to be improved in the haptics specifically, existing evaluation tools don't allow him to accomplish this. Furthermore, a limitation that might become evident throughout the entire process of building this system is the struggle of trying to communicate about haptics, be it when trying to articulate design goals or elicit feedback. And this can really only be expected, because currently there exists no language for touch that holds terms with consistent meanings, and users can typically only explain what they like or dislike, but struggle to articulate about touch sensations beyond that. And so to address these issues that hapticians like Raj face, in design, evaluation, and communication, we define haptic experience, a term that captures interactions with haptic technology belonging to a greater system. Furthermore, we've developed a model that defines its constituents, serving as the terms and constructs necessary to talk about and evaluate the haptic portion of any system, leaving hapticians like Raj with the foundations necessary to know what it means to have a successful haptic system and to achieve just that. And so I'll walk you through how we arrived at this model. So because we are defining a new concept, we took a bottom-up approach by bringing in a group of haptic novices. And so 8 individuals were brought in. Participants varied in their field of study, as well as their experience with video games, and each were limited in their knowledge of haptics. And so we began with a brief presentation to familiarize participants to haptic technology and its various applications. And at the end of the presentation, participants were given 5 minutes to independently brainstorm ideas in response to the question, what constitutes a good haptic experience? Ideas were then presented one at a time and clustered together based on related concepts. Afterwards, participants played a series of games on the Nintendo Switch, which is a system offering vibrotactile feedback. These games were selected based on the variation of haptic feedback intensity, diversity of effects, and the necessity of the haptics to complete the game. And so once all the games had been tested and they now had first-hand experience with haptic feedback, we again asked the question, what constitutes a good haptic experience? Any additional items were added to the first pool of ideas, and each cluster was assigned a label by the novices according to its theme. And so then we took the results of the novice brainstorm to generate a series of items. And so here are the novice brainstorm results in its raw form. An example of a category that the novices developed is variation in feedback intensity, which spoke to whether the haptic effects noticeably varied in their strength to reflect its purpose or what was going on in the context of the game. Another category that resulted was called combining the senses, which referred to how well the haptics matched the other sensory outputs the novices experienced at the time. And so these were two of the many categories that they developed, which were incorporated into our final model, and thus will be explained more in depth later on. We then looked at experts to revise these ideas and to add their own contributions. And so we began with an open card sorting task with the previously generated items. And so they were instructed to group items together based on their own set of criteria and assign labels to each cluster. And so the goal of this was to see how experts conceptualized how novice ideas should be grouped together. Then upon completing the task, we began a semi-structured interview. And so here we asked the experts to explain their thought processes behind how they organized the items, asked if any revision should be made to specific items, and then began a discussion about how they've evaluated haptics in the past. So the model was largely developed through the results of the card sort task, but the interviews also brought some really interesting insight into current methods and barriers for evaluating haptics. So, when asked how they've evaluated haptics in the past, the most commonly mentioned method was surveys, which was mentioned by 3 experts. One expert administered a self-developed scale after being unsuccessful in finding a similar tool in the literature. Another considered using a validated questionnaire, but found that a lot of the items were not directly applicable to haptics. And they stated, it would be great to have something similar that focuses on our needs. Furthermore, barriers noted by experts included the fact that evaluation methods tended to differ between hapticians, with one expert stating, it would be great to have a consistent tool because I think everybody at the moment is building their own approach. Another stated, it's very hard to compare your haptic feedback, your haptic device, with others because, of course, when everybody uses their own method to evaluate, it's very hard. Another noted barrier is the difficulty in drawing out useful language. One expert stated, a lot of people don't know what haptics is, don't know to expect it, so you're challenged to get people to articulate in ways that are useful to you. And so these interviews gave us insight into what limitations our model could eventually be used to address. And so we took all of our novice and expert feedback to develop the model itself. And so overlapping results between experts were combined, and then when possible, specific categories were selected over broader ones to create a more granular model. And so then constructs were labeled based on expert and novice suggestion or based on terms that already exist in the literature. And so after conducting our studies, we have defined HX as the following. A distinct set of quality criteria combining usability requirements and experiential dimensions that are the most important considerations for people interacting with technology that involves one or more perceived sense of touch, possibly as a part of a multisensory experience. We have also formed the constituents of the HX model. And so using the skeleton of many UX models, our model captures both the pragmatic usability requirements and the hedonic experiential dimensions of the experience. And so to go through the model, we'll begin with the design parameters. This is otherwise known as the HX building blocks, the aspects that are changed at the designer end to achieve the various components of HX. So in terms of haptic effects, timeliness refers to their temporal alignment with corresponding events. Intensity is the strength or magnitude of the effects. Density is the quantity of effects present within a given period of time. And timbre is their overall unique tone, color, or quality. Usability requirements then describe the functional aspects of HX that achieve a practical value in the haptic systems. And so utility asks the question, is it useful? And what it looks at is whether the haptics serve as this additional channel through which information can be transferred, either to enhance user performance or enable a skill that would not otherwise be available. Causality then asks if you can identify the source of feedback, whether the haptics are designed in such a way that the users can easily understand what caused it. Consistency is a technical requirement, asking if haptic effects reliably feel the same each time when they should. And lastly, saliency asks if the feedback is appropriately noticeable. In other words, does it capture your attention when it should, or does it blend in nicely in the background when necessary? We then have experiential dimensions, so the factors that achieve a hedonically enjoyable interaction. And so harmony was a dimension that arose in all expert results and noted multiple times as one of the most important themes for HX. So one of our experts stated that you can have a really simple haptic effect, but as long as it matches up well with the rest of the system, it can still be really effective. So Harmony asks, how well does a haptic fit in with the remainder of the system? How tightly coupled it's perceived to be with the other sensory outputs? Expressivity then asks if there's diversity in haptic effects and if they're each unique and distinguishable. Immersion refers to the level of engagement that haptic solicits for the user. Realism asks whether the haptic effect convincingly portrays what the user would expect to feel in reality. And lastly, Autotelics is a dimension that was actually suggested by one of our experts. It concerns whether the haptics feel good in and of themselves. And so Autotelics is a strictly hedonic-driven dimension, but it was included in this model because pleasurable haptics, apart from its context, can still contribute to a positive overall experience with the haptic system. And lastly, the model concludes with personalization support. So the ability for users to customize their experience to accommodate for individual differences in the perception and preference for touch. And so now with this model, we can now revisit where we noticed a gap in our field. What we weren't able to articulate about haptics before, we can now do so with the HX model to explain what elements of haptics contribute to a positive experience. So how can we use this model? Well, it can be used by various people in different roles. For example, for the designer, this model provides an organized template for thinking about design for haptic technology, a universal set of design markers that can lead to improved connections and collaborations between all kinds of designers. Then for the researcher, the model can guide future work. The model's constituents can serve as constructs that can be further explored in research. So for instance, exploring the influence of individual factors, searching for meaningful relationships between constructs, or determining if certain factors are prerequisites to others. Then, for the designer, researcher, and user, the model provides a set of vocabulary that can be commonly used to better articulate haptic experiences, be it whether you're trying to elicit or provide feedback. Furthermore, the model can now be used as a theoretical foundation from which consistent evaluation metrics can be developed that touch on haptics specifically. And so haptic-specific evaluation tools derived from this model permit users to more easily identify the strengths and weaknesses of a system, and then also allows designers to not only measure the improvement of their systems, but to have concrete data that vouches for the benefit of implementing haptic technology. And so the intention of this model is to unify designers, initiate the exploration of new haptic constructs, increase the ease of communication, and pave the way for consistent evaluation tools, all for the purposes of driving forward the field of haptics. Thank you very much.